our live coverage of EMO 2023 here in Hanover, Germany. And right now, I'm with a product that was probably the most discussed from our coverage of IMTS in Chicago last year, and that's the ORBITOOL. I'm here with Stan, who's going to give us a little tour.
Ian? Thanks for visiting us. A little pocket of the USA here in Germany. So this is the tool we talked about last time in Chicago. This is the ORBITOOL. It's our entire focus. It's going to be very simple. We'll just be talking about cross-hole deburring here. We're not going to be jumping around to any other topics. So this is a tool. Basically, we got this flexible shaft, carbide burr, and this protective ring on the end. That's sort of what's unique about the tool, what's patented about it, what makes it work so well. You can see up there, that's the ORBITOOL logo there. So we'll step over here. I'll just do a quick demo for you how the tool works. It's very simple. We use it by hand, manually with a rotary grinder, or on the CNC, mills, lathes, robotic arms. So here would be just in a little rotary grinder. There's that flexible tool. I'll spin it up at 15,000 RPM. I can put it right on my fingernail. There's no damage. Only when I go off the edge, we start deburring. So for manual deburring, that's a big challenge for folks when they have to go very carefully without scratching the part. In our case, you can just do it with your eyes closed. You're not going to damage anything. If you flip over to the inside here, let's find an edge that has a burr. So watch closely here. The moment I touch it, the burr is going to fly off. Spend a little bit more time, we generate a radius. But the disc is not damaging that part in any way. You can just run it right on your fingernail. So that makes it very easy to use for any internal holes.
This is really big, I would imagine, for high finished products.
Exactly.
Products where that surface is going to be really important.
Precisely right, yeah. So the challenge with deburring is you need a selective material removal. So you have this area where the drill's exited, you have a burr there, but that's not always a nice, clean, defined edge. Sometimes it's washing out into the wall. As you said, we can't damage the surface finish requirements, but even if it's not, let's say, a high precision surface finish, you can't have a gouge in there.
Right.
So ultimately, we need to remove the burr only at the intersection edge without doing any other dimensional changes. So in the manual setting, that's actually, even on its own without going to the CNC, it's actually a very efficient process. And we can actually see that here. Essentially what we just saw, this is what's happening real time inside the hole. You'll see the tool kind of stop here. So I'll just replay it real quick.
It's almost instant.
I mean, it really is. Tool comes in, you move it around. This is not sped up. Tool comes in, burr's gone, we pull it out.
I think one of the main advantages to that too, as you can see, there's no technique that needs to be learned. There's exactly no intensive training. It's, you can give someone this, we need this hole deburred, away you go.
We don't consider it like a craft sensitive technique. It's very easy for anyone in the deburring department. In fact, it's so easy, sometimes it's not even the deburring department. You'll have the machinist pull the part out of the machine. As they're running the next one, they can do it right there. You don't need a microscope or anything. Now here we have the same tool, same exact cutter. We go in the, just mount it directly, ER call it. Here's a brass part, a big heavy burr. The moment the disc drops past the wall, carbide hits the burr, cuts it off. Now we have a little sliver here. As we interpolate down, that sliver is going to come off, but there's no damage being made on the other kind of blended areas of the wall. And the program is just a helical interpolation path.
I was going to say, there's no magic tool path for this. That's a helix bore available in pretty much every single CAM program out there.
Exactly right, just like thread milling.
Exactly.
So very easy program. Ultimately, you're just deciding starting Z, finishing Z, and the interpolation diameter, that's all. And we can also, we recently got a CNC mill explicitly for process development, things like that. So we've got that. It's not running in our production or anything that's tied up. Customers can send us parts and we can develop the parameters and everything for them in-house.
And for customers who are doing this kind of process, what kind of industries do you find they're in?
I want to say all industries, and I'll kind of go over which kind of ebbs and flows of that. The simple way we put it is if you're buying drills and you're making holes, you're going to have burrs. So it's, cutting tools in general is sort of a canary in the coal mine for all manufacturing. Whatever industry is going up, they're buying more cutting tools. So we fit into that same line of mills and drills. After the drill, we call our tool the next tool after drill. So automotive is always obviously a big one. In recent years, we've seen a huge growth in aerospace. SpaceX using our tool, GE Aviation, Pratt Whitney. So aerospace has been pretty big lately. Automotive is always big. Medical, a little bit maybe for the smaller tools. We can talk about that a little bit later. We have some new small tools. And then the big one is hydraulics. I would say hydraulics covers everything.
Oh, okay.
If you're making hydraulic manifolds or hydraulic fittings, That could be a fitting that's going into a brake system in a car. That could be a fitting that's controlling, the various hydraulics on an airplane, landing gear, flaps, whatever. So let's say the general field of hydraulics, fittings, and manifolds, that's sort of our bread and butter, but those are going into pretty much all industries. Small tool I mentioned. So this is the full range that we have here. This is kind of the one that we've had for many years, down from a 1.8 millimeter here, which is a 74 thousandths, so roughly speaking for 2 millimeter holes, and then up to our largest cutter here is a 3/8 cutter. So we would use that on 1-2 inch holes. The beauty of the ORBITOOL is because we're interpolating around the hole, we don't need a crazy skew selection for 1.2, 1.3, 1.4 millimeter holes. You pick any tool that fits the hole and you interpolate the diameter, that's it. And then back here you'll see the double hemisphere, what we refer to as the double hemisphere tool. Actually, let's go back here maybe, this we can see it obviously here. Yeah, there we go. We have the half sphere, single hemisphere, the double hemisphere tool. What's that one for? We can see that here. That's to deburr cross type intersections. When a T or an elbow, we use the single hemisphere. Double hemisphere continues on to deburr the farther side edge. So that's very common in hydraulic manifolds where you might be drilling through the bore, but not all the way through the back of the part. So that you can only deburr it from that entry point where you drilled it. So that's the purpose of that double hemisphere tool. And beyond this one, I think, here's another quick CNC video here. So here's an aluminum part. Previously we showed you the stainless part, brass, this is aluminum. It's another beauty with the ORBITOOL is we don't have a bunch of complex shapes or, with drilling and milling, all of those fluid angles and RPMs really react differently to different materials. This tool, because it's flexible, because we have very fine cutting fluids, it's acting much more like a filing or a grinding. So it's the same exact range that we're using from aluminums and brass all the way up to titanium.
Oh, so you don't need to have a specialized one, like you say, a higher fluid angle for aluminum,
exactly.
Or, more flutes for a harder material. If I grab one of these, throw it in my machine, it could live in pocket 20 the entire time, no matter what material or size I'm running.
Exactly. So we do see that with a lot of customers where as much as everyone would love to automate everything, you don't have an unlimited amount of tool holders or cycle times. So some customers do approach us with that intention of, can I just have one tool and kind of let's plan to use this on a range of holes. Even in this video, you can see this is I think a 1-inch hole on aluminum. But the tool size we're using, I believe, is our 3/16 cutter.
So that's actually a very small cutter
Super
compared
small
to the size of the hole.
Yeah, but it's obviously generating plenty of radius. Most folks aren't requesting 30, 40, 50 thousandths radius size. So from the standpoint of removing the burr, deburring, edge break, it's more than enough.
The one thing I find really interesting about this as well is it's about as close to as a standardized finish you're going to get consistently over holes that I've ever seen.
That's a good way to word it because I don't think people view deburring as a standardized thing. Drilling and milling's all worked out. You get this drill, you have this RPM, you have this feed rate, you calculate your cutting feet per minute, whatever, it's standard. Deburring is still sort of we have this person using this type of scraper, this type of, and people end up using 10 different tools and 10 different operators to try to deburr. Obviously, it's not possible to do 100% of everything, but in general, we do view this as this one tool, kind of one size fits all.
And the one thing, if you see someone grab a belt sander and you say deburr this part, one guy's going to have a 40 thou radius on there, another guy's going to have a 10. At least with this, they get that process control.
That's
even if they're doing it by hand, because it's only going to go so far.
That's a good point. So manually, again, similar to this other aluminum part, we have this, I believe it's a 5/16 inch hole here. So let's say we go to our 1/4 inch cutter. This is the largest tool that's fitting in the hole. Yeah. But for this entire show, I'm using this 1/8 cutter, which is 3 sizes smaller. And just by angle this, we can see the, let's see if I can bring this in. We can see the chamfer as it's developing there. So that, as you mentioned, if you want to limit the amount of work you're doing, you want just an edge break. Even in a manual setting, if I choose this small tool, that's already going to, kind of be a limiter to how much work the operator can do.
They can't accidentally cut too much.
Exactly right. Because some customers, yeah, they really just want to edge break, but they don't want a radius. Spool valves, for example, you need a sharp corner for the seal to go past. In other, elbow and T fittings, it's the opposite. They want a very large radius for flow reasons, for stress concentration reasons.
And if people want to find out more about ORBITOOL, where can they go?
Easiest thing is our website, jwdone.com. That stands for Job Well Done. You can also just search ORBITOOL. We've been selling this for 20 years, so we don't really have to pay for any Google ads. It'll show up on the top. Just if you search
It's the best product that's still blowing people's minds
I
20 years later.
I appreciate to hear that. Thank you, Ian.
Thank you very